Okay, so let's go through the homework. I hear my dog in the background. She's chosen this exact moment to get upset about something, but we'll work through it. So if you hear a barking dog, it's our dog bravely guarding us against the UPS truck. Anyway, so I'm going to go through the homework assignment. Most of you guys did pretty well with this, so I don't really... I'm not going to spend a lot of time on this. There are a fair number of slides, but I'm going to go through them pretty quickly. Most of you guys were doing really well translating this and evaluating this argument, So let's look at the first one. So Jane and Pete won't both win the math prize. Pete will win either the math prize or the chemistry prize. Jane will win the math prize. Therefore, Pete will win the chemistry prize, right? So remember, like I said, let's take this step by step. What are the facts this talks about? Well, Jane and Pete win, Jane winning the math prize, Pete winning the math prize, Pete winning the chemistry prize, right? So 3 different symbols. J equals Jane will win the math prize, P equals Pete will win the math prize, and C equals Pete will win the chemistry prize. Again, y'all can use whatever symbols you want, just, you need 3 letters to stand for these 3 facts that it talks about. So now that we have the letters, take our statements, we can just strip this down, put it in this distilled form, numbered premises conclusion. Once we've done that, next step, we can substitute symbols for each of the numbered premises, right? So Jane and Pete won't both win the math prize, number 1, not J and P. Excuse me. Number 2, Pete will win either the math prize or the chemistry prize, P or C. 3, Jane will win the math prize, J. Finally, conclusion, Pete will win the chemistry prize. Well, I don't know, well, you'd say easiest, but one way to prove this, of course, one of the ways you could do this is to just use the truth table method, right? Remember our premises. Our premises, we have 3 of them. J and P, P or C, and J, right? So let's look on the truth table. Let's find the lines where all of our premises are true. Well, there turns out to be only one, line 3 here. Well, lo and behold, in the one line where all of our premises are true, our conclusion is true as well. So anytime all the premises are true, conclusion has to be true as well. You can see the premises in red, conclusion in blue. That shows that this is a valid argument. If you guys did it this way, that's fine. Works perfectly. 3 letters, 3 variables. We're going to have 8 different lines, but if you want to do the work, works perfectly well here. We could also use the valid forms of argument I've talked about, and if you want to do this is the shortest way I see to do it, right? I guess you can be shorter if you want to be lazy about some steps, but if you just want to spell everything out, which I think is a good practice here, this is the shortest way to do it. So, right, our 3 premises, not J and P, P or C, J, right? Well, a few more steps we can get from these to our conclusion, right? So first step, not J or not P. Remember De Morgan's rules where you can use that on number 1. Not J or not P is the same thing as not J and P, right? All right. 5, double negation. Remember, J or whatever letter is always equivalent to not that letter, so J is the same as not J. Double negation on 3. Well, now we can use the process of elimination on 4. That gets us P. And, gets us not P. Not P if we use the process of elimination on 2. Gets us C. You can use this to show it's a valid argument. A lot of you guys actually did it. This stuff's kind of complicated. We're not going to do a lot of this formal proof. I just want you guys to get a sense for how it works. Okay. Second argument had roughly the same form. Ever so slightly different in details, but more or less works the same way, right? Either John or Bill is telling the truth. Bill and Sam are not both telling the truth. Sam is telling the truth, so John must be as well. Again, 3 different facts it talks about. John is telling the truth, Bill is telling the truth, Sam is telling the truth, right? We've got our letters for the statements. We can move on to either John or Bill is telling the truth, J or B. Bill and Sam are not both telling the truth, not B and S. Sam is telling the truth, S, so John must be as well. Just means John is telling the truth, so J, right? So, again, we can use this truth table method, right? There is, again, only one line where all of our premises are true. Again, line 3. And on that line, our conclusion is true as well. Premises I've highlighted in red here, conclusion in blue. Hopefully you guys can see how the truth table proof works, right? If we want to use these valid forms, we make roughly the same moves with this argument as we did the last one, right? J or B, not B and S, S, well. So 4, B, not B or not S, De Morgan's rules again. 5, not S, double negation again. 6, not B, process of elimination once again. And then finally, J, again, process of elimination, right? So hopefully none of that's mysterious to you guys. Like, I don't think it is. Most of y'all did pretty well with this. Most of y'all seem to understand the basic ideas here. All right. If you do have any questions, send me an email, put something up on the discussion board, or even call me. Do not be afraid to call me. I have the phone on me especially during office hours, which are among other times when we'd normally be having class. The phone, I always have it on me. I will pick up. So, if you guys have problems, want to talk about something in class, just feel free to get in touch with me. I am here. All right, anyway, but that's it for homework. Going to move on in the lectures to talk a bit more about conditionals now.